Welcome. This is a side-by-side comparison of two identical large language models, Quen 2.5 3B, running differently on different sessions. So on the left, I'll be running Quen 2.5 3B first, and on the right, later after Quen 2.5, the standard model, I will run the same model, but this one will be integrated with Brain, a persistent habit memory layer that learns from feedback. So we will test three things. One, a cross session memory. Two, spontaneous recall without reminders. Three, learning from user feedback. Let us begin. So I will load Quen 2.53b first, and I will start prompting it by introducing my name first. And I will tell the model that I have diabetes and we'll see what and how he responds. My name is David. I have diabetes. So we'll just give it a few seconds to respond. This model is running currently on my model l- laptop, which is not running on a very powerful GPU. So you respond. The conventional response from LLMs, it greeted me, and you just repeat what I said. You can just add it on information that diabetes can be managed with the right approach and so on, so forth. So now I will continue by prompting, should I buy soft drink, and see what it says. Now, obviously, the answer will be no because currently Quen is running on the same thread, so it shares the memory. But problem starts when you switch it off and you restart to another session, you will have the memory gap. But just to let you know, a lot of large models, larger ones, like the popular ones, they do have sort of a persistent memory because how they do is they will save the user's interactions in a permanent memory, and they will retrieve it cosine similarity, so they will match the words that was being mentioned in the earlier thread with the words that is being mentioned in the current thread. So if there are some similarity, it will bring up that earlier words. So but sometimes the problem is that that way of retrieving, it can be not so contextual because what you spoke about in the previous thread may not directly relate to the thread that you are conversing now. So that is the problem. Okay, now we have the response from Gwen. Give me a list of things to avoid and what I should do, which is very good. Now, so what I'll do is that I will quit the session very quickly. I'll quit the session. I have mentioned my name. I have told that I have diabetes, and see if he remembers. So I quit the session and we come back again. Give it a while. So take some time, and I will load it back again, and I will ask the same thing. Instead, I will ask what's my name because I already mentioned my name and that I have diabetes, right? So I will ask what is my name. Should not be able to respond to me because this is a new session. Seems like you might be asking, what is my name? But you haven't provided a name. You see, it forgot. All right. So we will switch to the other model that is being enhanced with brain, and we'll see what the difference is. Let it load. It will take a while. I will repeat the similar question and introductory dialogue is loading. So I will say my name is David. I have diabetes. Now the brain recalls the user has diabetes. Give it a while. It's inferencing. Okay, so he gave me an answer. Hi, David. It's great that you are taking an active approach to managing your health by acknowledging, addressing your conditions of having diabetes. Okay, so the difference between with this model, brain, uh, is that it allows Gwen to learn, be fine tuned while it is running, right? It is not like normal transformers where you need to stop and freeze the model to do fine tuning and all that. In this one, you can actually live uh, train as it goes. So I'll just say yes. This will strengthen the Herbian learning, and it become much more aware. Now I will ask the same question. Should I buy soft drinks? Now it's thinking and recalling the past information about my condition and all this information about me. The good thing about brain is that it is a different kind of learning process, which is different from RAG. Uh, we use neural synaptic injection directly into the model's layers before the attention mechanism. So he gave me an answer straight away. He says that it's not recommended to purchase or consume soft drink if you have diabetes. This is really, really specific to my condition. So you can see the difference. You know, the standard models give a very generic advice. It does not mention diabetes specifically, or give the impression that it is concerned about my diabetic conditions, right? Because it's already forgotten. Whereas Gwen with brain, it still remembers. Okay, so this clearly demonstrates the advantage of attaching brain into an LLM. Thank you so much.